Hello.
Please introduce yourself.
Hello, my name is Tariq. I'm from Eulitha. I'm a strategic director for marketing, and we are here at Display Week in Los Angeles.
Hi.
I'm Kelsey Wooley. I'm the Director of North American Operations, and we're here showcasing our unique lithography solution for...
What is unique about what you do?
Great question. Yeah, so what we do is we're doing a mask-based interference type of lithography that's called Talbot, that's able to produce very high resolution structures in very large fields, and to do this very quickly and very inexpensively. So we're able to image an entire 140 by 140 millimeter exposure field in one single exposure, providing a seamless patterning capability for our customers. And the resolution can get down to 60 nanometer half pitch, so DUV capabilities. And these wafers are running 30 wafers per hour up from there. So it's a very fast, very low cost. Our tools are far less expensive than a projection type of structure. Platform. Just making sure Tariq's not getting stuck in the microphone. So we sell to a lot of AR, VR, laser customers, telecom gratings, any sort of R&D that's based around photonic structures or diffraction gratings, polarizers, you name it.
Is this stuff that has to do with displays or chipsets or both, or
displays? Yes, displays. So in order for the mask-based interference to work, it needs to be a pattern that has periodicity. So it needs to have something that is replicated over the exposure field in order to get the high enough resolution. So we're not printing IC circuits, but we're printing line space structures or lattices or holes or pillars or other large area periodic patterns.
And this is crucial for the future of displays, or for what?
Oh, certainly. So, our business is built around the ability to make these large field patterns for a fraction of the cost of some of the other solutions. We're much faster, much less expensive than, say, an E-beam competitor, and it's much more reproducible and much more reliable than a nano imprint solution. And that's where
the E-beam using, or what is the E-beam?
It depends on what everyone's doing. People use E-beam when they don't need, or if they don't want mask-based work, or if they need to do very small patterns. E-beam is okay for that. It's good for R&D, but E-beam doesn't scale. And so we get a lot of customers that have been using E-beam for years. They developed a product that's at the maturity level that they want to take it into manufacturing, and they need some sort of lithography solution that can take them there. So we usually come in at that point where they're ready to start making more structures faster, and cost becomes important.
What's the Fable R, Fable X, Fable S? Is that your big machine?
They are. So they're the three tools that we sell. The Fable R, the R stands for research-based. It's a tabletop, which we've got a picture of over here.
Yeah, this one?
Uh-huh. So you get all the benefits of the optics, but it's very low entry cost point for ensuring that you can build your full flow based on this type of lithography.
So who's going to be buying these?
So we get anywhere from universities all the way up to large customers that need to do R&D first. So this utilizes the DTL patterning, but it's very straightforward, very small footprint, very low entry price to see that that's the technology they want to scale with. When they're ready to scale, we have the Fable X. I'll pull this out for you.
Yeah.
Which does the same high resolution optics, but it starts adding larger wafer sizes and automation. So you get a front end robot that does cassette in, cassette out handling. You have a post exposure bake, for example. It becomes much faster, much higher throughput, much more reliable with a semi-automation system. And then when customers are ready to go all the way to 300 millimeter, we have a step and repeat system. So the unique thing about this tool is it takes that 140 by 140 millimeter exposure field and it step and repeats it over the larger wafer. So you're able to utilize the whole wafer with that large seamless exposure field. And so this is full automation. So FOUP in, FOUP out, cassette in, cassette out. Also automatic mask handling. So you don't have to touch masks. It's really set for high volume.
When people make millions and billions of displays, do they use stuff that could be related to this, or
yes, mm-hmm.
Or are you doing lithography in a way that's unique? Nobody else does
Correct.
Exactly that.
Yes.
Do you have many customers already, or you're new in this?
Yes. So Eulitha has been around for about 10 years and has been growing for 10 years. Where the first models were only the R, the tabletop, and just kind of a university R&D focused tool. And then in the last 5 years or so, we've come out with the X for the customers that are ready to scale to that level. And then due to the drive of the market, we have just in the last year started offering the 300 millimeter platform.
So can you explain a little bit to, let's say, non-expert, how does this become a display?
Yes.
Where does
so
it go?
Yeah, so it depends on the display. So I am to augmented reality, like we have a lot of customers that use this for waveguides. So for example, if your waveguide is based on diffraction, you would need to create line space diffractive gratings on the surface of your eyepiece. And so those gratings are line space nanostructures at a certain pitch, a certain size, to control the light input and output over that large space of eyepiece. So these line space structures become extremely important to fill that eyepiece, so that these are the diffractive elements. So we control the pitch, the size, the grating orientation that go into the design of making a really good augmented reality waveguide.
It could be a company like Ghous, maybe.
Yes, definitely.
Maybe it's could be working with a company like you. People who make
AR, VR,
which is going to be huge.
Yes, a lot of customers. This is a booming industry.
And other markets?
Yes.
Does it go in projectors? Does that work for that?
Yeah, so we have some customers that are in like micro LEDs. Anything bigger than that, they can use typical mask aligners for that type of lithography. It's really the micro level where mask aligners can no longer do that type of lithography, that they start to have to look at nano imprint or projection, and we're a lower cost solution to that.
All right. What am I seeing here?
Yeah, so this is a 6-inch wafer with a 4-inch exposure field. Our exposure fields can be much larger than that, but these are just holographic elements. And so these are those diffractive gratings that I was speaking about, that they're nanostructures that kind of capture the LEDs in this display and it just light up and make it glow. So we have customers too that use our tools for creating holographic elements.
Nice. And what's the Swiss flag? So is that the headquarters?
Yes. This flag here.
All right.
That is, they're based in Kirchdorf, which is about 25 minutes out of Zurich. So all of our tools are manufactured in Switzerland.
So it's precision.
It's precision,
it's
yes.
Microelectronics. It's micro technology stuff. I mean, that's what the Swiss kind of say sometimes.
Yes.
And then there's office in the US?
Correct. So I run the US operations, and our office is up near Seattle in Redmond, Washington.
Cool. All right. Thanks a lot.
Yeah.
Thank you.